to verify Kirchhoff's voltage law and study its limitation. This is the aim. In any closed path, mesh or loop for any electrical circuit, the algebraic sum of product of current and resistance in each of the conductor plus the algebraic sum of electromagnetic forces in closed path is 0. Okay, a circuit, closed circuit, only one loop is there. Okay, so here is a positive supply, here is negative supply. This is resistor R1, this is resistor R2. Let's suppose that A, B, C, D is a closed loop. Okay, this is a loop. Loop is equal to A, B, C, D. Clear, everyone? And suppose I am passing some current across this particular loop. The current is flowing through this closed loop as I. Okay, so what is the voltage across this R1? What is the voltage across this R2? I into R1 is the voltage across this, and this voltage across B2 is equal to I into R2. Okay, I, same current is flowing, but resistor is different. And what is the voltage across this? The voltage across this battery is B. Okay, so according to this Kirchhoff's voltage law, sum of all the EMF plus voltages is equal to 0. Section is horizontal section. This one is horizontal section, and another section is vertical section. This is vertical section. This is second section, and this one is your first section. First section is horizontally connected with each other. Okay, all the connections are horizontally connected with each other. That means if you apply, let's suppose that I am applying this connection to ground. So all the connections are horizontally grounded. Okay, and this is again the horizontal section. If I apply 5 volt, okay, to this connection, so these horizontal connections are connected with plus 5 volt. Okay, so our target is to create a circuit for KCL. Okay, this particular multimeter show different sections. Okay, so this particular section is called a digital display, where you can see all the readings related to that particular calculation. You can see right here. This is a continuity beeper. Continuity beeper is used to check the wire connectivity. Okay, let's suppose that this is our wire, and this particular wire is broken at this particular position. Okay, so how to check the connectivity? You have to connect one ground position to one terminal, and you have to connect positive to the another terminal. This is terminal 1, this is terminal 2, but this particular wire is broken inside the insulation. Okay, and when this wire is broken, this circuit is not going to complete, and this buzzer will not be start beeping. Okay, if this wire is connected with each other, then automatically this circuit will complete, and this beeper will beep the sound. That means your wire is okay. If there is some break, then wire is not okay. Now next one is resistance. Okay, so this symbol is present on the multimeter, ohm sign. This is ohm sign. This symbol represents the resistance. When you move your knob toward this ohm sign, that means you are going to calculate the resistance of particular resistor. Okay, so here we have a resistance. Let's suppose that we have a resistance and we want to calculate that resistance value. Okay, so let's suppose that I am placing that resistance right here. Okay, so what you will do, you will place the positive terminal at T2 point and ground terminal at T1 point, and place your knob toward this ohm sign, and you will find the resistor value right here. Okay, next thing, AC voltage. What do you mean by AC voltage? AC voltage, that voltage which is coming at your home place. Its frequency is this 50 hertz supply is used in our households. Okay, so this AC voltage you can measure while placing your multimeter knob toward this V tilde symbol is applied. That means you have to calculate the AC supply, which is the DC voltage. When you represent V minus, that means this dash symbol represent the DC. Okay, that means this is a DC supply. Okay, so there is no frequency for the DC supply. Okay, why that there is no frequency? Because it is constant at every point. Let's suppose that this is voltage and this is amplitude. Okay, and this is the DC voltage. Let's suppose that this is a 3 volt. So amplitude remains same at all the levels. Okay, what do you mean by selection switch? Selection switch is used to select the particular level where we have to calculate that value. Okay, if you move this particular switch toward this point, that means you have to calculate the frequency. If you move this knob toward this side, you have to calculate the voltage. If you move this switch toward this point, you have to measure the current. Okay, if you represent this symbol, that means AC current. If it is represented toward this dash line, that means DC current. Okay, so there are two currents, AC current and DC current. Whenever you move your knob toward that particular position, and we have to mention the potential difference notation right here. When this potential difference is rising, we consider positive notation. When this potential difference is falling, we consider negative sign convention. Okay, so when you pass through this current across this particular circuit, this is to be considered right here as a negative voltage. Okay, so this voltage should be right here minus of I1 into R2, and this voltage across this R2 resistor is minus of R2. Clear everyone? V minus I into R1 minus I into R2. It has some horizontal lines and it has some vertical lines. So these horizontal lines are connected horizontally, whereas these vertical lines are connected vertically. Okay, so when you connect any connection right here, all these connections are shorted with each other. So this is called a resistor. Okay, this is called a resistor. It has different colors. You can find out the resistor value with the help of this color coding. This is called multimeter. This is called multimeter. When you change the knob to the particular position, you will find different values related to that particular component. Okay, everyone? This is called the probe. Okay, this is called the probe. One is positive. Okay, this red and this is black. Red is positive, black is negative. Clear, everyone? So when you want to connect to the circuit or find the value of any of the component, you can connect these two probes to find out the values. Okay, everyone? You will click on this circuit, and here you will find green button. When you click on this, new window will appear. You can see this is the 9-volt battery that is connected to the switch. Okay, when you press on to this particular switch, the current will flow through the circuit. Okay, And across this register we have placed one multimeter that is connected parallel to this particular register. So whenever you want to calculate the voltage, you have to select the multimeter in parallel. That's why we are using this multimeter in parallel with the register. So every time when you want to calculate the voltage, you have to connect this multimeter in parallel to the resistor. Find all the components right here. If you want a resistor, you can drag this resistor and drop right here. You can rotate this resistor using this rotation key. Okay, you can rotate this resistor. If you want to delete this resistor, press the delete key from the keyboard. Okay, when you want to select the multimeter or voltage, okay, you can select this voltage from here. You can rotate this voltage to any level. Okay, when you want to select a switch, okay, you can select that switch like this. There are three terminal. Terminal 2 should be positive, terminal 1 should be negative, and common is connected. When you press on button, then it will pass the current, otherwise it will not pass the current. It will remain off. Okay, and from here you will find multimeter. You can select that multimeter using a drag and drop key, and you can place positive to the positive connection, negative to the negative connection. The multimeters are showing zero voltage. When I will press this switch to the on position, then it will show the voltage 2.99, 2.99 and 2.99. Why it is showing the same voltage? Because I have used all the same registers right here. Okay, you sum up all these voltages, that will be equal to the 9 volt, and if you sum up all the EMF and voltages across the closed loop, that will be equal to 0. So what is the calculation part right here? What is the calculation part right here? Sum of the EMF plus voltages should be equal to 0. So 9 volt minus 2.99 volt minus 2.99 volt minus 2.99 volt is equal to 0. So if you sum up all those voltages, that will be equal to 0. So that will verify our Kirchhoff's voltage law.